What you're hearing is raw electromagnetic radiation data captured by the Cassini spacecraft at Saturn's North Pole. It isn't just white noise. It's the sonic footprint of a magnetic powerhouse, a celestial entity spinning at 35,000 kilometers per hour, warping the very laws of physics in its wake. This force dictates a grim mathematical frontier, the Roche Limit, the tipping point where Saturn's tidal gravity overpowers the structural integrity of any celestial body. 100 million years ago, an icy moon wandered into this trap and was torn to shreds. But instead of plunging into the abyss, centrifugal force locked the remains into a skeletal halo of debris. But here's the problem. This system is unstable. Latest observations reveal that Saturn is digesting its own jewelry through a phenomenon known as ring rain. Every single second, 10 tons of matter are being siphoned into the atmosphere by the magnetic field. The most magnificent rings in the solar system are, in fact, committing a slow-motion suicide. Why is it vanishing so fast? And why are we lucky enough to be standing here, right now, to witness its final, dying gasps? As we established, Saturn's radio screams are the pulse of an extreme gravitational and magnetic field. But why does a simple pull possess the power to rip a solid world apart? The answer lies in the differential. Picture an icy moon drifting toward Saturn. According to the laws of gravity, the side facing the planet feels a stronger pull than the side facing away. At a safe distance, this gap only creates tides. But cross the Roche limit, and that gap becomes lethal. The stretching force on the leading face grows so violent it overpowers the internal gravity, holding the moon's molecules together. In other words, the moon doesn't just fall like a stone. It is dismembered in mid-orbit. Data from the Cassini mission points to a name, Veritas. 100 million years ago, this moon may have harbored an icy ocean, until its orbit drifted off course. When Veritas hit the Roche limit, it didn't detonate like a bomb. It was stretched into an ellipse, then it snapped. In a matter of days, a monolithic world transformed into a 100,000-kilometer ribbon of shrapnel. This explains why Saturn's rings are 99% pure ice. This isn't ancient cosmic dust. It is the fresh flesh and bone of an executed moon. So why didn't this debris plummet immediately? Orbital velocity. Every shattered ice crystal retained the frantic momentum of its parent moon, screaming along at 70,000 kilometers per hour. At this speed, centrifugal force pushes outward, perfectly counterbalancing the gravity pulling inward. They are locked in a state of eternal suspension, haunted by the very spot where their mother world died. Saturn didn't just tear a moon apart. It froze the moment of the massacre to create the ring we see today. The balance between centrifugal force and gravity we just analyzed. It's a static illusion. In physics, nothing stands still forever. Especially not when billions of shards from the moon Veritas are drifting through a gauntlet of extreme magnetic fields and radiation. The problem starts with the very nature of this debris. Because these rings are 99% pure ice, they are hypersensitive to solar ultraviolet light. When the sun hits them, these ice particles ionize, taking on a positive charge. Instantly, they cease to be mere players in Newtonian mechanics. They become puppets in the grip of Saturn's colossal magnetic web. This is where the radio screams you heard earlier reveal their devastating power. Saturn's magnetic field isn't just noise, it's a gargantuan funnel. These electrified ice grains are seized by the field, their orbits warped, dragged along spiral paths toward the planet's poles. Scientists call this ring rain. The logic of this self-destruction follows a relentless chain reaction. Ionization. Sunlight transforms ice into charged particles. Loss of momentum. The magnetic field exerts a Lorentz force, sabotaging the 70,000 kilometers per hour orbital velocity that kept them suspended. Decay. As velocity drops, centrifugal force fails. Gravity wins. The result? 10 tons of matter plummet into Saturn's atmosphere every single second. Based on mass loss data from Cassini, the speed of this digestion is staggering. Saturn is devouring an Olympic-sized swimming pool of material every 30 minutes. At this rate, the most magnificent ring system in the solar system will be wiped clean in less than 100 million years. A mere blink of an eye in cosmic time. But the most chilling part isn't that the rings are vanishing, it's where they're landing. When 10 tons of ice slam into the atmosphere every second, they don't just evaporate. This massive influx of water and chemicals is radically altering Saturn's ionosphere, fueling extreme climatic shifts, the monstrous hexagonal storms we see today. We aren't just observing a ringed planet. We are witnessing an entity cannibalizing its own past to feed the superstorms of its present. So, what happens at the final impact point of this ring rain? What bone-crushing pressure awaits beneath those hexagonal clouds? Ready to grind the last remains of the moon Veritas into nothingness? When 10 tons of ring rain vanish into the atmosphere every second, they don't just disappear into the void. They become high-octane fuel for the most brutal weather machine in the solar system. To understand why Saturn screams and how it sustains such impossible geometric storms, we must look beneath the amber veil deep into the churning core. Our first stop, the Hexagon. This isn't an optical illusion or a cosmic coincidence. It is a perfect hexagonal megastorm, twice the width of Earth, with unnervingly straight edges. Physically, this hexagon is the byproduct of extreme velocity gaps between jet streams. With gases screaming at 1,800 kilometers per hour and no solid surface to provide friction, the vortices self-organize into stable geometric structures. But what haunts scientists is how this flow seems anchored by a titanic upwelling of energy from the planet's depths, where pressure begins to snap every known molecular structure. The deeper we go, the more Saturn's cruelty reveals itself through sheer force. Thousands of kilometers down, hydrogen as we know it ceases to exist. Under millions of bars of pressure, hydrogen atoms are crushed so tightly that electrons are stripped from their nuclei, forging a sea of liquid metallic hydrogen. This is the heart of the beast. This layer of metallic fluid acts as a colossal dynamo. The convective churning of this electrified liquid generates a terrifying magnetic field that enshrouds every moon and ring in its path. The radio screams we record are the raw output of this process, the mechanical roar of an engine grinding matter into pure energy. But in this high-pressure hellscape, there is a phenomenon that turns brutality into ultimate luxury: diamond rain. In the deep layers, pressure cooks methane, stripping carbon and compressing it into raw diamonds that hail down toward the core. But make no mistake, this is no treasure trove. Before any diamond can fully form, temperatures soaring to tens of thousands of degrees melt them into a liquid carbon ocean. Saturn builds nothing to last. It crushes everything, from moons to diamonds, into a state of chaotic flux to fuel its eternal rotation. So, if the mother planet is a pressure cooker that brooks no life, why are the satellites sitting right on the edge of this death zone our greatest hope? Why just outside the Roche trap is life perhaps flickering beneath the ice? The existence of Saturn's moons is living proof of a brutal physical schism. Stay just beyond the Roche limit, and matter is granted the chance to create rather than be executed. While the mother planet is busy crushing debris and melting diamonds, a completely opposite script is unfolding just past that deadly frontier. Enceladus is the prime example of this contradiction. A tiny, frozen jewel, yet it erupts with colossal geysers firing pure water into the vacuum of space. Here, the very tidal forces that dismembered the moon Veritas serve as a life-giving furnace. Positioned safely outside the Roche trap, Saturn's pull isn't strong enough to shatter Enceladus, but it is enough to knead its rocky core, generating the friction heat that keeps a liquid ocean swirling beneath the ice. In a strange cosmic loop, the water spewed from Enceladus is seized by Saturn's magnetic field, feeding the E-ring. A moon silently nurturing the very ring system of the giant that nearly crushed it. Further out lies Titan, the only moon in the solar system with a thick atmosphere and rivers of liquid methane. Titan is a dark, frozen mirror of Earth, but its peace is a trade-off. It sits far enough to escape the tidal shredder, yet close enough to be imprisoned within Saturn's lethal radiation belts. Every complex organic molecule on Titan is the byproduct of the radio screams bombarding its atmosphere, a chemical alchemy that many believe is the precursor to life itself. The existence of Enceladus and Titan presents humanity with a haunting paradox. The environments with the highest potential for life sit directly adjacent to the most ruthless meat grinder in the cosmos. This led to the most tragic sacrifice in the history of space exploration: the death of Cassini. In 2017, as the Cassini spacecraft ran dry on fuel, NASA scientists faced an ethical ultimatum. They could not let Cassini drift aimlessly. A rogue collision could contaminate Enceladus with Earth-borne bacteria, forever tainting the search for pristine alien life. NASA issued a final suicidal command: dive into the heart of Saturn. In its final moments, the craft fought against the bone-crushing pressure to transmit one last data stream: the chemical fingerprints of the ring rain falling from above. Cassini wasn't just destroyed, it was vaporized, ionized, becoming a permanent ghost within Saturn's atmosphere. The end of Cassini is the ultimate testament to this planet's logic. To understand the secrets of life and beauty, we must accept destruction. Saturn did not just cannibalize its moons, it swallowed humanity's final messenger, closing a chapter of history, just to keep the flickering hopes on Enceladus untouched. Saturn's rings are more than just a wonder. They are a grim foreshadowing of the Kessler syndrome right here on Earth. The rings are, in essence, a graveyard of density, a zone where any spacecraft daring to cross is instantly obliterated. Earth is currently forging its own Roche Limit out of technological waste. Once satellite density hits a critical mass, a single collision will trigger a chain reaction, transforming our orbit into a lethal belt of shrapnel screaming at 28,000 kilometers per hour. Both share the same terminal outcome: imprisonment. Saturn imprisons the corpse of the moon Veritas in a gravitational loop before slowly digesting it. The Kessler syndrome will imprison humanity beneath our own atmosphere, turning space into an inescapable cage. We will gaze up at a ring of debris surrounding us, not a crown of glory, but a testament to technological suicide. The truth is, the beauty we admire is merely a glitch in time. In 100 million years, as the old rings fade into oblivion, Saturn will lure its next victims, Enceladus, Mimas, into the Roche trap to recycle a brand new set of rings. The universe does not operate to maintain stability. It thrives on the recycling of destruction. Saturn will remain there, cannibalizing its children to sustain its hollow splendor. As for us, will we learn the lesson written in those fragments before we finish locking the door to the stars? If Saturn showed us what gravity can do to a ring system, Venus shows what heat and pressure can do to an Earth-sized world. They call Venus Earth's twin. But that name hides one of the harshest planetary failures in the solar system. Similar mass, similar structure, completely different fate. Hotter than Mercury, crushed beneath a supercritical atmosphere, buried under a sky where blue light no longer survives. In the next episode, we descend into Venus, Earth's twin, broken by physics. In planetary physics, giant planets are not supposed to go quiet like this. A world as large as Uranus should still be leaking a meaningful amount of heat from its interior, leftover energy from its formation slowly escaping across billions of years. Neptune still does. In fact, Neptune radiates about 2.6 times the energy it receives from the Sun. Uranus, by contrast, emits only slightly more than it absorbs. Recent work puts that excess at roughly 15%. That is the anomaly. Not that Uranus is cold, not that it is distant, but that a giant planet of this size has become so thermally quiet. And once that comparison is on the table, the problem stops being atmospheric, visual, or superficial. It becomes structural, because Uranus and Neptune are supposed to belong to the same planetary family. They are similar enough that, at first glance, their deeper thermal behavior should at least rhyme. But it doesn't. One world still behaves like an active thermal system. The other sits close to silence. So the real question is no longer, what is wrong with Uranus? The real question is, what kind of interior allows a giant planet to fall this quiet while a world so similar to it does not? That is where the story begins. A giant planet is supposed to release a meaningful amount of internal heat. That is one of the most basic expectations in planetary physics. These worlds form hot. They store enormous energy in their interiors, and over billions of years they slowly radiate part of that energy back into space. Neptune still does exactly that. It emits about 2.6 times the energy it receives from the Sun. Uranus does not. Uranus sits close to thermal balance, giving off only slightly more energy than it absorbs. It is not completely inert, but for a giant planet of its scale, the excess is strikingly small. That is the measurement that changes everything. Because once the problem is stated this clearly, distance is no longer enough, temperature is no longer enough, and classification is no longer enough. The question is no longer whether Uranus is cold. The question is why a giant planet of this size is releasing so little heat in the first place. And that is where the deeper instability begins. Uranus and Neptune are similar enough that their thermal behavior should not diverge this sharply without a physical reason hidden beneath the surface. If one world is still radiating strongly while the other is nearly quiet, then the difference cannot be superficial. It has to be structural. Something inside Uranus is not behaving the way our simplest giant planet picture would predict. Either heat is not being transported upward efficiently, or the interior itself is organized in a way that prevents that energy from reaching the outer layers. So Uranus does not force us to question the laws of physics. It forces us to question the ease with which we thought we had already understood giant planets. And once that shift happens, the next step becomes unavoidable. We have to stop looking at Uranus as a cold outer world and start asking what kind of interior can produce this kind of silence. If that is the fracture Uranus opens, then the next question follows naturally. Once classification stops being enough, we have to move inward, because the only place left to look is the one place we cannot see directly, the planet's interior. And this is where the Uranus problem becomes much more unsettling. The simplest explanation would be to assume that Uranus is quiet because it has already lost most of its heat. But that explanation is too shallow. The deeper possibility is harder to picture and far more important. Uranus may not be quiet because the heat is gone. It may be quiet because the heat can no longer travel upward efficiently. That changes the entire story. In a giant planet, internal heat does not matter only because it exists. It matters because it moves. Energy rises from the deep interior toward the outer layers, and one of the main processes that allows that to happen is convection. Hot material rises, cooler material sinks. And through that motion, a planet slowly releases the energy left behind by its formation. But Uranus may not have an interior that mixes freely enough for that process to work in the way we expect. One of the strongest possibilities is that Uranus is compositionally stratified. Instead of behaving like a well-mixed interior, it may be built from layers of different composition and density stacked in a way that resists large-scale overturning. In that kind of structure, convection becomes inefficient. Heat is not erased, but its route to the surface becomes obstructed. That is the point where Uranus stops looking like a cold planet and starts looking like a blocked system. The visible atmosphere may not be the clean expression of a world that has simply gone cold, It may be the upper skin of a planet whose internal energy is still present, but trapped below layers that no longer communicate properly with the outside. And that is why Uranus matters as more than a thermal anomaly. Because once a giant planet can keep heat and still appear this quiet from the outside, the problem is no longer just temperature. The problem is transport. The problem is structure. The problem is the hidden architecture that determines whether a world can release its energy or bury it beneath its own interior. So the real shift in this story happens here. We are no longer asking whether Uranus is cold. We are asking whether Uranus has become thermally silent because its interior has learned how to trap its own heat. And once that possibility is taken seriously, one more question becomes impossible to avoid. What could have built an interior like that in the first place? At that point, the story stops being only about heat transport and becomes a story about planetary history. One of the strongest explanations is the giant impact hypothesis. Uranus is not just unusual in temperature, it is also unusual in orientation, rotating with an extreme axial tilt that already suggests a violent event early in its past. And if a collision was powerful enough to tip the planet so dramatically, it may also have been powerful enough to reorganize its interior. That is what makes the impact idea so important. It is not just a visual explanation for why Uranus appears to be lying on its side. It is a structural explanation for why Uranus may no longer behave like a normal giant planet from the inside out. A collision on that scale could have melted, displaced, and redistributed material throughout the planet. Under extreme pressure, that rearrangement may have produced stable density layers, compositional boundaries, or a deep insulating region that weakened convection and slowed the escape of heat. If that happened, then the thermal silence of Uranus is not an isolated feature. It is part of a much larger system. Its tilt, its weak internal heat flux, and its unusual interior may all belong to the same physical history. And that changes how Uranus should be read. It is no longer just a cold giant. It is a world whose present behavior may still be carrying the consequences of an ancient disruption. In that sense, Uranus is not merely quiet, it is structurally altered. And that is what gives the planet its real significance. Not that it is mysterious for its own sake, but that its current state may only make sense if we treat temperature, structure, and history as parts of the same story. So by the time we arrive here, the question is no longer just where Uranus's heat went. The deeper question is whether Uranus became thermally quiet because its interior was rewritten very early in the life of the planet itself. By the end of this story, Uranus no longer looks like a simple cold planet at the edge of the solar system. It looks like a world whose silence has to be explained from the inside out. What begins as a strange thermal measurement turns into a much deeper physical problem. Uranus is not quiet because physics has failed. It is quiet because the physics of heat transport inside a giant planet may be far more complicated than our simplified models once assumed. That is the real lesson Uranus leaves behind. Not that it is an impossible world. Not that giant planets are beyond explanation. But that surface similarity is not enough. Uranus and Neptune may belong to the same planetary family, yet Uranus shows us that category alone cannot explain outcome. To understand a giant planet, we have to ask how heat moves, how matter is layered, and how an ancient event can continue shaping a world billions of years later. And that is what makes Uranus so important. Its silence is not empty, it is diagnostic. It tells us that the deep architecture of a planet can matter more than the label we place on it. So in the end, Uranus is not just a cold giant. It is a giant planet whose present state may only make sense if heat, structure, and history are read as parts of the same system. And that may be the clearest thing Uranus teaches us. A world does not need to break the laws of physics to surprise us. It only needs to follow them in ways we were not yet ready to understand. Across the silent reaches of the void, there lies a world dying in brilliance. They call it Earth's twin. But here, the light perished billions of years ago, held captive beneath an eternal shroud of amber. At the base of its valleys, the pressure is as dense as an ocean. A silence so heavy it could stifle any sound. We are not merely looking at another planet. We are gazing into the grandest tomb in the solar system. The beauty of hostility. Venus looks like a lie. From a distance, it's a soft, silent ivory, perfectly still. But that glow isn't coming from water clouds or anything that might harbor life. It's actually the glare of sunlight, violently reflected off thick, lethal layers of sulfuric acid. Look beneath that jewel-like exterior, and you won't find a paradise. You'll find a furnace of crushing pressure and heat, ready to swallow anything that touches the surface. The moment you cross that line, the thrill of discovery turns into something else. A primal fear, because you aren't just flying into a planet anymore. You're sinking. It's a deep-sea dive into an ocean of air so thick there's no foothold and no way back. As the white veil above fades away, you realize you're being consumed by something vast, nameless, and deathly quiet. When the blue vanishes, this is where the light fails. Every blue wavelength, the color of our sky, the color of hope, is choked out by the atmosphere. What's left of the sun is a murky, suffocating amber that stains everything it touches. You've entered a world where a blue day simply doesn't exist. This is a kingdom of yellow shadows, where even the last scrap of light feels like it's decaying. At the bottom of the Venusian atmosphere, the line between gas and liquid simply vanishes. With pressure 90 times that of Earth, carbon dioxide is forced into a state called a supercritical fluid. This isn't air as we know it. It's a thick, heavy soup of matter, so dense that it could actually keep you buoyant. Standing here, you're not just enduring pressure. You are standing at the bottom of an ocean of liquefied gas, where every movement is a struggle against the massive, frictional drag of a world packed too tight with molecules. In this dense soup, sound doesn't behave. Because the air is so tightly packed, sound waves travel faster and hold their energy much longer than they do on Earth. The result is a kind of acoustic chaos. Mechanical groans from the planet's crust, miles away, can ring in your ears as if they're right behind you. But there's a catch. The atmosphere also acts as a filter. It swallows high-pitched noises, leaving only a low, muffled thrum. You'd feel constantly hunted by phantom noises you can't trace. An auditory torture in a world that's always whispering, yet completely devoid of life. The isolation here is amplified by a strange optical trick, super refraction. The air is so thick it actually bends light to match the curvature of the planet itself. Here, the horizon doesn't drop away like it does on Earth. Instead, it seems to curve upward, giving you the haunting illusion that you're standing at the bottom of a giant, amber-colored bowl. Your vision is trapped, choked by the scattering of light in a medium so dense that space seems to fold in on you, leaving no visual escape to the stars above. In that supercritical state we mentioned, the atmosphere of Venus doesn't just crush the Venera probes. It finds a way to seep inside. With its extreme density, this gas-liquid hybrid crawls through the tiniest microscopic gaps in the titanium hulls, dragging lethal heat directly into the ship's core. These probes aren't just fighting the heat. They're besieged by a substance with the force of a liquid, but the invasive power of a gas. It's a silent, molecular invasion, one that renders every layer of armor utterly meaningless. Think about those 127 minutes, the record for survival set by Venera 13. That's 127 minutes of machinery screaming under the strain, in a world where lead and zinc have already turned to liquid. Every image sent back to Earth was a miracle of defiance. But when the last welds melted and the circuits finally snapped, the probe didn't just die, it was assimilated. In that instant, the line between high-tech engineering and a lifeless rock vanished. The ship became part of the Venusian geology, a twisted hunk of metal claimed by the pressure of an ocean of air. Because there's no water or sandstorms to erode them, these wrecks are still there, sitting exactly where they landed over 40 years ago. They exist in a state of eerie preservation beneath the acid mists. In this vast, lonely world, these shards of titanium are the only fingerprints of humanity. They lie there, silent in the amber gloom, like ancient tombs of a civilization that never had a chance to begin. It is a small, haunting presence, a reminder that this universe was never built to welcome us. The lonely wrecks we see today rest on a surface that wasn't always this hostile. Computer climate models suggest that for billions of years, Venus and Earth might have shared the same brilliant beginning. There is solid scientific ground for a time when this planet possessed liquid oceans and stable continents. It was a near-perfect double, a true twin, where life might have once flickered into existence. The suffocating silence we find today is actually the echo of a paradise stripped away by the cruel, grinding gears of the cosmos. The shift from a lush blue world to an eternal furnace didn't happen overnight. It was driven by a terrifying phenomenon, the runaway greenhouse effect. As solar radiation intensified, water vapor began to evaporate at an uncontrollable rate, creating an irreversible heat trap. The oceans boiled away, and heated carbonate rocks bled their CO2 into the sky, forging the supercritical atmosphere we saw earlier. This is the ultimate proof of a climate system that crossed the point of no return, where the laws of physics took over to dismantle a world. The isolation of those Venera probes lying in a graveyard of basalt is more than just a chapter of space history. It is a mirror. When we look into those murky amber horizons and feel the crushing weight of Venus, we aren't just observing another planet. We are witnessing a possible future for Earth, should our own fragile balance ever shatter. Those rusted hulls are the first relics of a warning, a vision of a world where the blue of our oceans is a distant memory replaced by an eternal silence and the dying yellow light of a ghost planet. After all our attempts to penetrate its secrets, we are met with a quiet truth. Venus does not hate us. It simply has no need for us. This planet is not a battlefield, but a vast entity operating by the purest laws of physics. Amidst the blackness of space, it will continue to spin, brilliant under the sun, yet solitary within its supercritical shroud. Humanity's titanium footprints will remain there forever, veiled in acid mists, like tiny grains of sand unable to stir the silence of a world that has chosen to close itself off from life. A world like Venus serves as a stark reminder that life on Earth is not a given. It is a fragile miracle, woven from a series of cosmic accidents. Let the murky amber horizons and the suffocating weight of our twin become a silent warning from the dark, so that when we look back at our blue sky and breathe the gentle air of home, we might cherish every breath this planet gives us, before it all becomes nothing more than an amber memory drifting in the eternal void. The most brilliant planet in our night sky is, in truth, the universe's most perfect lie. This grand illusion triggered one of the darkest chapters of the space age. While America celebrated its victory on the moon, the Soviet Union became obsessively, almost frantically, haunted by our planetary neighbor. They quietly poured billions of dollars into launching dozens of gargantuan machines, armored in monolithic titanium, solely to pierce through that impenetrable fog. Why did a military superpower so stubbornly hurl cosmic tanks into an unknown world? Cold War conspiracy theories once whispered a chilling scenario. Soviet intelligence had glimpsed something at the bottom of that ocean of mist. An invulnerable strategic outpost, or a perfect world to serve as a final sanctuary? But when those steel titans finally touched the ground, what they found was more brutal than any hypothesis. To pierce that shroud of mist, the Soviet Union knew they couldn't send fragile satellites. They forged cosmic tanks. Weighing 5 tons, these machines encased their electronic brains within monolithic titanium spheres, material born to build the world's deepest diving nuclear submarines. In Moscow, engineers stress-tested them in extreme hyperbaric chambers, proudly believing that human metallurgy could conquer any risk. But they were wrong. The atmosphere of Venus is not a problem to be solved. It is a physical execution chamber. The metallic pride of the Soviets was, in truth, nothing more than toys about to be gnashed by nature. To witness the exact moment that pride is utterly crushed, we will join the Venera probes in a terminal freefall. The descent into the floor of hell begins now. The Soviet Union entered this exploration with the innocence of those who had never known hell. The first 3 missions, Venera 1, 2, and 3, never even caught a glimpse of their enemy. They were cooked alive by thermal failures, lost in the vacuum, or plunged into silence before they could even pierce the upper atmosphere. Venus rejected every frail visitor. It wasn't until 1967 that Venera 4 made history, bracing itself to dive through the pale yellow haze. At an altitude of 50 kilometers, the first signals transmitted a flicker of false hope. The environment at this cloud layer seemed temperate, with pressure and temperature mimicking a warm day on Earth. But that was nature's most sadistic deception. This murky veil, tens of kilometers thick, was utterly void of water. It was woven from concentrated sulfuric acid, a corrosive fluid with the same metal-eating bite as battery acid. The cruelty lay in the weather mechanics. The Venusian sky does have rain, but the laws of physics have twisted it into an endless torture. These acidic downpours are never permitted to touch the ground. As the acid droplets fall, the searing heat billowing from the surface boils the mid-air at an altitude of 25 kilometers. The acid evaporates back upward, creating a perpetual chemical loop suspended in the sky. Venera 4 wasn't flying through a cloud. It was free-falling through a gargantuan acid bath. Its metallic skin began to be gnawed away, and external sensors shrieked in the face of corrosion. But this wall of acid was merely the outermost defense. As Venera 4 sank deeper, leaving the suspended rain behind, it was about to encounter a crushing engine, one that would forever stifle its breath and sever its lifeline before it could even sight the floor. Past the suspended acid rain, the probe continues its plunge into the darkness. But from an altitude of 15 kilometers down, a maddening physical phenomenon begins to take hold. Every law of earthly aerodynamics that Soviet engineers once hailed officially becomes scrap paper. The deeper the machine sinks, the more the space around it distorts. The Venusian atmosphere is 96% carbon dioxide. Under the colossal weight of gravity, this massive volume of CO2 is compressed so severely that it transcends the boundaries of ordinary matter. At this depth, the sky is no longer a gas. Brutal pressure has forced it into a supercritical fluid, a physical monstrosity possessing the expansion of a gas, but the crushing density of a liquid. At this moment, external pressure on the hull skyrockets to 92 times that of Earth's surface. To visualize this brutality, the pressure crushing the titanium shell is equivalent to being submerged 1 kilometer deep in the Pacific Ocean without a pressure chamber. You cannot use a parachute to land in an environment like this. When the early Venera generations attempted to deploy their chutes, they realized a horrific truth. They weren't falling through air. They were sinking slowly into an invisible ocean. The drag was so thick that the descent became an agonizing crawl. Consequently, those proud hulls were buckled and flattened like empty beer cans by the atmospheric press, dying mid-air before they could even sight the floor. Venus taught humanity a bloody lesson in the power of physics. To have any chance of survival, the Soviets were forced to rewrite the entire concept of exploration. By the time of Venera 9, they made a radical decision. They discarded the main parachute system entirely. They redesigned the probe to resemble a deep-sea bathyscaphe, equipped with a solid steel drag disc at the top. This disc didn't generate lift to fly. It functioned as an aerodynamic anchor, utilizing the very density of the supercritical atmosphere to brake, allowing the 5-ton mass of metal to slowly sink to the bottom of the abyss. But even as this great submarine braced itself against thousands of tons of pressure to touch the ground, what welcomed it was not victory. The thud of landing was merely the starting pistol for a countdown to a far more sadistic torture. The 5-ton submarine finally strikes the fractured basalt surface. But the thud of metal hitting the ground is no triumphal fanfare. On Venus, a successful landing is merely the starting pistol for a lethal countdown. The titanium hull, once the pride of the Soviet Union, is now officially a prisoner at the bottom of a CO2 ocean. While the crushing pressure strangles it from without, its ultimate end will come from a far more sadistic torment. This place is a thermal trap, locked at a staggering 475 degrees Celsius. It all stems from a physical catastrophe known as the runaway greenhouse effect. The massive atmosphere acts as a perfect insulating blanket. It permits solar radiation to enter, but absolutely refuses any path for heat to escape. Contrary to our visions of a chaotic hellscape, the surface of Venus is void of howling gales or shredding storms. Its cruelty lies in a thick, stagnant stillness, motionless in a heat fierce enough to liquefy lead, tin, and zinc. Any machinery cast into this abyss will be boiled from the inside out. But the Soviets refused to yield. In 1982, they hurled their most resilient machine yet into this pit, Venera 13. Armored to the teeth and carrying the most sophisticated liquid nitrogen cooling system of its time, it was a desperate bid to buy time against the inevitable. But against the ruthlessness of nature, human preparation was tragically frail. That great cosmic tank gasped for breath for exactly 127 minutes. In those 127 minutes of terminal agony, just before the heat cooked the circuit boards into a metallic soup and the pressure welded the camera lens shut forever, Venera 13 managed to open its eyes and transmit historic color images. The first color panoramic images from the surface of Venus by Venera 13. What humanity saw shattered the final illusions. There were no secret military outposts, no lush, misty tropical jungles. Under a jaundiced light, warped by the dense atmosphere, the picture revealed a bleak, orange wasteland of jagged volcanic rocks, hauntingly silent. That landscape isn't just a planetary surface. It is the remains, the soulless corpse of a world that once possessed vast oceans, just like Earth billions of years ago, before its own atmosphere turned traitor and boiled everything into oblivion. We began this journey with the illusion of a second Earth and the frantic pride of the Soviet Union. But in the end, what we brought back was not the glory of conquest. It was a forensic report of an extinction. The Soviets hurled their most advanced metallurgy into this physical slaughterhouse, only to leave behind nothing but titanium coffins. Even now, the machines that were once the pride of a superpower lie dead and broken on the scorched basalt. There will be no rescue mission. No world power dares to send another robot into that abyss. But the final image from Venera 13 serves as a chilling warning. Earth and Venus were born as twins, sharing the same starting line. If we were to boil our own atmosphere with our own hands, that desolate photograph wouldn't just be Venus's past, it would be Earth's future. Standing before the cosmos, this waterless ocean remains, the most brutal and perfect rejection of humanity's grand delusions. But Venera left behind one harder question. What kind of world can turn air into an ocean, warp sound into a whispering trap, and bend light until the horizon itself begins to close? Stay with me, because in the next chapter, we descend into the supercritical silence of Venus itself.